Hi viewers, this is Sri Ramlu. So today I have come with good topics, that is CC configuration, common collector configuration. So what is the common collector configuration of transistor? Common collector configuration of transistor. In common collector configuration, collector is common for both input and output. See, collector is connected. So here arrow mark is shown, means that is emitter only. So there is no arrow mark, means it is a collector, it is a base always. Next, hence the input is applied between base and collector. See, input is applied in between base and collector, and corresponding output signal is taken between emitter and collector. So emitter and collector. So it is output section, it is input section. Now collector terminal is grounded as shown in figure. Yes, it is grounded here. So that is we are appearing clearly. Next, current gain or amplification factor. The ratio of output current to input current is called current gain. Right? So here output current is emitter current, input current is a base current. So that is why IE by IB. So it is a for DC at constant VEC. At constant VEC. Okay, so it is a for AC. And in CB, in common base configuration, current amplification factor is shown by alpha. In common emitter configuration, it is shown by beta. In common collector configuration, current amplification is shown by gamma. So that is why here gamma. See, input parameters BBE and IB, VEC and IE. These are the output. These are the input parameters. Next, input characteristics. The variation of input current IB with input voltage VBC at constant output voltage BEC is known as input characteristics. That means keep it constant and change this value and note down the corresponding value. Again change this value, note down the corresponding. Again change this value, note down the corresponding. So change means continuously increase this value and note down the corresponding values. Next time VEC change now. So at the beginning, so see here the diagram you can understand. At the beginning it is kept at 5 volts and have taken the values of what VBE and IB, and later again the VE is changed as 10 volts, and again they have taken the values of VBC and IB. So again they have like this, they have taken the different values and drawn the graph here also. First, keep VEC constant and vary means change VBE values and record IB values at each input voltage of VBC. Repeat the same process at a different output voltage values. Now plot the graph between IB and VBC parameters. So values. Okay, graph. So that's such a graph we get. Figure shows input characteristics curve in CC configuration. It is common collector configuration. The characteristics curve shows that at constant output voltage VEC, the base current does not increase initially everywhere in every. Suppose if you observe the CB and the C also, current cannot follow the voltage. After applying certain voltage current, then only current starts. Okay, does not increase initially till reaches a voltage known as cut-in or offset voltage as shown in figure. Later it increases with the base collector voltage VBE. Okay, it increases with VBC, that is the meaning of base collector voltage. As the collector emitter voltage, that is VEC, is increased above 5 volts. See here, above 5 volts means 10 volts, the curves shifts away from the current axis. See, first current axis for first time we got line this, next time we got. So that means the current is lagging behind the voltage. But in the previous, if you observe the VBC current leading only. So that means you may find the before only, current starts before only when you change output voltage. Because reason is that here depletion region width increases with increasing VEC in the region. So this is the reason because of what? Depletion region. What happens? Its width increases. Output characteristics. See output characteristics. Variation of output current IE with output voltage VEC at constant current IV. This is known as output characteristics. So in output characteristics, always we have to keep input voltage on input current constant, and change VC, note down the IE at a different VC, different IE values we have to get, and if you draw the graph, then we can get such a graph. Okay, these curves resembles output characteristics of C configuration. Okay, so it is similar to the C configuration. Resemble means it is similar to C configuration. The output characteristics of C and CC configuration are same. See, output, so reversible means the same thing. So whatever present in a CE, same values are present in CC. Common collector configuration is also called as emitter follower. Why? Because how much emitter current present, collector current also present, same thing. So that is why it is called emitter follower. And it is used as a buffer circuit for matching their impedance. So it is used for impedance matching only, which is CC configuration used for impedance matching. So that is why in application also given C, it is used in impedance matching. Its application used in impedance matching. Okay friends.